Alright, so got a video here for you, video lesson. It's the first part of section 8.2. We're continuing to talk about how we mix calculus with exponential and logarithmic functions, and today we're looking at the derivative of the natural log. And just like e has some very unusual and useful properties with calculus, obviously the natural log would too. So first thing, let's think about our old rule for integrating. All right, we take and we add 1 to the exponent, and then we divide by that number. And remember, that only works if n doesn't equal -1, because if n equals -1, then I'm going to be dividing by 0 on the bottom, and I can't do that. So we need a rule for this. What are we going to do when n does equal -1? And we'll actually get to that a little bit later this chapter. I just want to give you the rule so that we can actually do some work today. So I'll explain this right here a little bit down the road, but the integral of x to the -1 is the natural log of x plus c. Remember the constant of integration on any indefinite integral. So if the natural log is the integral, then we can go the opposite way with this and say then that the derivative of the natural log must be x to the -1, or 1 over x. I mean, it works both ways, right? Integration is just the opposite of differentiation. But that's pretty specific, right? Remember, that only works if it's exactly the natural log of x. And that doesn't happen very often. So just like we have the last couple days, let's expand this rule to the natural log of other things. Alright, and so we have a more generalized rule for this. And so this is the more important one for the day. So the derivative of the natural log of anything, and we've been calling it u lately. The derivative of that is going to be the derivative of the u divided by u. Okay, so whatever that u is, if that's 2x, then it's the derivative of 2x over 2x. Okay, if it's 7x squared, then it's the derivative of 7x squared over 7x squared. So I'm just going to give you a lot of examples right now, and I really like to see you push pause after each one of these as you can and try it first before I do it for you. So the first one, the function is the natural log of 3x. Okay, so here's the derivative. Remember, push pause if you want. Alright, so the derivative of that, so what's the derivative of 3x? 3 over 3x. Of course, I can cancel those 3's out, and I'm left with 1 over x. Alright, that is the derivative of the natural log of 3x. Okay, second example. Not a very hard one. Again, push pause after each one of these if you want to try it first on your own, rather than just watching me do these. The natural log of x to the 3rd plus 5. So, hopefully you've tried it. Alright, if you've done the work, the derivative of that is 3x squared over x to the 3rd plus 5. Okay, so we're just taking the derivative of the inside part there and dividing it by the whole thing. Alright, continue to try to make these a little bit more difficult here. So now the function is x to the 3rd times the natural log of x squared. So again, push pause before you see me do it. Now, the derivative for this one, I'm going to have to use the product rule here. Alright, I got a couple of things that are being multiplied together here. So it's going to be the derivative of the first part, which is 3x squared, times the second part, the natural log of x squared, plus the derivative of the second part, which is going to be 2x over, 2 over x times x to the 3rd. Okay, because why that is that's actually 2x over x squared, and I canceled one of the x's out. Okay, and then I simplified there a little bit, and that's my final answer there. Okay, So I skipped a little step there. Hopefully you understand what I did. Way back there, that was 2x over x squared, and I canceled one of the x's out. Alright, let's try another one here. Try to be a little clearer on this one for you so you can see the work that I do. So I'm taking the natural log of x, all of that to the fourth. So you're going to push pause if you want. So here I'm using the chain rule. So chain rule like we've used it before. I'm going to treat that whole thing inside the parentheses like it's u. And so the derivative of that would be 4 times that whole entire thing to the third times the derivative of the inside part, which is just 1 over x. And I can write that a little bit differently and just write that as 4 natural log of x to the third all over x. Again, you can slow this down, go back, press pause, listen to it again, try it again as many times as you want. Don't just sit there and watch me do work, but try to do some of it yourself. So natural log of the square root of x plus 1. So I'm just going to rewrite that as x plus 1 to the 1/2. And now I'm going to chain rule this again. So I'm doing some rewriting here. Sometimes you can rewrite it and it will make it a little bit easier. So if I chain rule this right now, so that would be 1/2 times the inside part to the negative 1/2 times the derivative of the inside part, which is just 1. I'm going to put all of that over x plus 1 to the 1/2. Okay, so remember, it's the derivative of that over that thing itself. Remember, the derivative of u over u. And so I do a little rewriting here. If you're trying to figure out where I got that from, take that negative 1/2 power to the bottom and that 1/2 power that's already down there and add those together. That's going to be x plus 1 to the first. So that's how I simplified that. Alright, next one. Natural log of x times the square root of 1 minus x squared. So what we're taking the natural log of is getting a little more complicated, and now you have to start using log rules. So remember, if I'm multiplying those things together, I can split that apart with an addition sign. And I can also treat that as 1 minus x squared to the 1/2. And since that's a power, I could actually rewrite that then as 1/2 natural log 1 minus x squared. So by using your log rules, you can simplify these quite a bit, and your derivative work will be a lot easier. So if you can use log rules, really recommend doing that. Now take the derivative, really easy now. 1 over x plus 1/2 times the derivative of the inside part, negative 2x, over 1 minus x squared. Do a little simplifying here. I can cancel out the 2 on the top and the bottom. So I got 1 over x plus negative x over 1 minus x squared. Remember, if you can simplify somewhat easily and obviously, then go ahead. And this isn't too bad. I just got a common denominator here. So I'll multiply the first fraction by 1 minus x squared. So I get 1 minus x squared over x times 1 minus x squared. And then the second fraction, I just have to multiply that by x. And so that's how I got that second x squared. Simplify that, 1 minus 2x squared all over x times 1 minus x squared. That's a relatively simplified answer. Again, lots of log rules, and then a little bit of derivative work at the end. Alright, last example. Try to put it all together here. So natural log of a mess. X times x squared plus 1 to the squared over the square root of 2x to the third plus 1. So log rules are really important right now in this problem. So remember, if I'm multiplying here, I can add natural log of x plus natural log of x squared plus 1. But since I got that squared up there, I can pull that exponent out in front and call it 2 times the natural log of x squared plus 1 minus, make my square root be a power of 1/2 and pull that out in front. So 1/2 natural log of 2x to the third plus 1. So again, log rules are going to make each of those problems much easier than the whole thing. So now I can take the derivative of each individual part. The first one is 1 over x. Second one is 2 times 2x over x squared plus 1. Then the last part is minus 1/2 times 6x squared over 2x to the third plus 1. That should really be 6x squared. Not sure if I'm going to remember to do that or not, but I needed to. And so if I do a little simplifying here, that's 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x to the third plus 1. Alright, last thing we're going to do here on this video tonight is just to do an application with these derivatives. And so what I'd like you to do is find and classify the critical points of the following function. Remember how to do that. A couple step process here. Again, once you see, if you want to push pause and try to do it on your own before I show you how to do it, go for it. So x minus the natural log of x. Alright, step 1. Find the first derivative and set that first derivative equal to 0. Again, if you want to press pause and see if you can do that, go for it. So my first derivative is 1 minus 1 over x. Set that equal to 0. Do a little bit of algebra there, cross multiply, and I get x equals 1. That's a critical value there. I also have a critical value of x equals 0, since 0 would make it undefined. Okay. I don't have to do any work with 0, since x equals 0 will just be an asymptote in this problem. So the next part of this process then is to classify what kind of critical value 1 is going to be. So how do I do that? Take the second derivative of this function, and once I take the second derivative of this function, I'm going to plug in 1 and see what the behavior of the second derivative is. So, like I mentioned before, I don't have to really do anything with x equals 0. That's an asymptote, so I don't have to plug that in. That isn't going to work out. But let's take the second derivative now. So, don't mind me here. I made a little mistake here on what I'm doing. Let me erase all this. This is a little confusing here. Let me go back to my first derivative again. My first derivative, if you remember, my first derivative in this problem was 1 minus 1 over x. My first derivative was 1 minus 1 over x. Now I'm going to take the derivative of that. So derivative of 1 is 0. This is really negative x to the negative 1, so the derivative of that is then going to be a positive 1 over x squared, or x to the negative 2. Now I can go ahead and plug in my critical value. I'm going to plug in 1 for x, and I get 1 for my answer. 1 is a positive value, so that means that the function is concave up. Remember, if the function is concave up, that would make 1 a minimum. So that's how we classify that critical value. Okay? So, if you would, please work on some homework problems here, and that will help you get a little bit of practice for the quiz that you'll have coming up here after we finish this section tomorrow. Alright, so page 540, 9 through 35 odd. Thanks.